11 to noon for our longtime South Coast Telescope and Astrophysics Club, the Santa Barbara Astronomical Unit. It's watchable on YouTube. And we are ready for the 17th of October through the 23rd. That is episode 86. Let's meet the gang. On my screen to my right is President Jerry Wilson, up for re-election in December, as I am. To my left is our, well, actually, he's married to the first of two wonderful ladies named Pat Porgy. Everybody happy out there? Wearing your mask still, Jerry?
Yeah, we're doing good.
Got dogs, cats, and everything else. Is like Chuck McPartland, our outreach coordinator in front of the flag from Ukraine. His wife is our merchandise manager for the club, Pat. Tom Totten joined us moments ago, our official webmaster, technical wizard, former president, and usually asks some pretty good questions if I don't think of them. And there is Tom Whittemore, who's married to Maureen, editor of our Santa Barbara Astronomical Unit newsletter, Tom, and an incredible baker of sourdough bread. Todd is married to Suzanne, and we're going to talk about shapes and patterns in the night sky. Asterisms are us. Which galaxies made it into the closing credits of the Outer Limits TV show? And anybody know? We might tell you this hour. Goodbye to Pan Stars. Hello to C2022 ER. That's a new comet in town. Meteor shower possibly Friday night based on the Orion Nebula or the Orion, I guess, what is it? It's
Constellation.
The constellation.
Okay, so it's out of there. That's probably the radiant. Well, we have the SBAU Kachuma camp out and picnic this weekend, right, Chuck?
Yep.
Okay, and people are signing up for it. I hope I can make it. I hope I'm signed up, but my car is in the shop and they keep calling me, and telling me, oh my God, we got to do this to it too, And a webinar tonight, if you're interested. You want to tell us, Chuck, before we get into anything of the silly cartoons, what's going on? Outreach?
With the there's a webinar that you have to sign up for at the museum. So you have to have gotten the link or go to their webpage and get it. And it's just on a launch for an Earth observation satellite that's going to go out of Vandenberg.
Oh, okay. One that we won't see otherwise except on the webinar, or they're just going to talk about it. It's called JPSS, right?
Yeah.
Is it Joint Polar Satellite System? Because they got to be launched from Vandenberg to go north or south. Okay. How about the sillies that you send us online, Mr. President?
Sure. Before I do that, I just want to mention that Lucy passed by the Earth yesterday.
Oh,
One of her swing gravity assists.
Levi Parillo, was that his name?
Yeah.
Anyway, he talked to us a couple of Mondays ago about that.
it was cloudy.
Oh, okay.
It was cloudy for us, but there are some images up on spaceweather.com of the pass.
Okay, this is the two dogs in space talking while looking up at the night sky. One says to the other, if NASA sets up a moon base, they should take a dog with them. We'd guard their equipment from galactic pilferers. The other dog says, I see a flaw in your plan, which is, well, in space, nobody can hear you bark. True, or scream. Why is it a bad idea to major in physics? This one is very interesting, and you labeled it too true, Jerry. Portion of the pie chart says the math is hard, but a bigger part declares you'll never enjoy action movies again as long as you notice the wrong physics in the damn thing.
It was an interesting looking series that started on one of the subscription channels, and people were in the trailer. People were going up in a space elevator, and as they're accelerating up, all of a sudden things inside the cabin started floating as if it was in zero gravity, which is
Really?
exactly wrong. I never watched the series.
Oh man, there's still a theory out there of putting a space elevator. They need that special carbon filament that's stronger than spider webs, isn't it?
Everybody needs at least an elementary school teacher in science as a consultant on the film.
That's true.
Some of these errors are major bozos.
And this cartoon you sent us, a silly, would be close to the heart of our last speaker on October 7th. That would be the head of the science and physics department out at UCSB. Something inside the Hadron CERN collider in Switzerland is whispering to the scientists, "Psst, hey, why don't we just say I'm broken down and we both take the rest of the day off, huh?"
This is the Large Hadron Collider.
Oh, colluder. I missed that. Okay. I meant to ask him and I never got around to it. Well, I'll tell you what my question is here in a minute.
Okay.
Okay, Pete, we have one of the private rocket companies that are starting up around the country. Okay, Pete, start the pressure nice and easy, and it's a water hose connected to the wall, and you have to turn the faucet. Works for me. Works.
Okay, that's the list for today.
Okay.
Now, before we get to today's program, see if I can get back to it here. There was something that we didn't get to last week, and it's a nice graphic, so I wanted to show it.
It's a
Oh,
solar-
not the planetaries one.
Yeah.
Oh, it's got the Crab Nebula in there again. That's not a
Oh,
planet.
yeah, that's right, it does. But in old terminology, whoops, but it's a good
Oh.
graphic.
Yeah.
As far as it goes, where is the crab? I don't see it.
Second row left.
Yeah.
Oh, yeah, there it is, yeah. Yeah, these are, that's the only one that's a supernova explosion. The rest of them are all solar type eruptions of shedding the outer shell. But we had talked about shapes a little earlier, but this is much more extension of the various shapes. Technically, it is a planetary in old terms, like 1800s. Because it's a
Well, it's a
small
nebula. They
round
called
thing.
it a nebula, but I don't know that they called it a planetary. 'Cause-
Okay, okay.
Yeah.
Okay, anyway, it included this one down here that has, it looks like sort of a box-shaped antenna. And that one's always been very intriguing in my mind, trying to look at it in several dimensions.
And I think that's called the Red Box Nebula, actually.
Yeah, yeah.
Okay, now are these shots from the web?
These shots are, these are from the Webb, but not the James Webb. It's from the World Wide Web.
Yeah.
Oh, really? So maybe most of them are from the Hubble.
Yeah.
A lot of them could be.
Yeah,
They're
that's
these
good.
very small objects. But
Oh,
you see, they come in a lot of shapes and stuff. And as we've discussed before, some of these, like this one and this one, if we were oriented along the axis, would look like probably this one or this one. It would look like a ring to us.
Mhm.
So they're very, and we discussed the mechanism before, just as a review. These are largely determined by the environment of the star and the condition of the star, its rotation, and how much crap it's thrown off before, and whether it's inside of a dust disk or not that blocks the stuff coming out. So a very nice graphic, except
I
for
think
that
there's-
one flaw.
I think there are two cat's eyes in there too, one above the other,
Yeah.
just in different wavelengths.
You think
So
that's
what
the same ones?
I think they are, yeah.
Hmm.
Cotton, what were you saying?
So what can you tell from the different colors going on there?
Some of it's false color.
Yeah. Virtually everything you see in astronomy is false color.
So there's
But
only one.
in general, like on the Ring Nebula down there, the red is nitrogen, green is oxygen, yellow is sulfur, pink is hydrogen.
If you look at these through, if you're doing visual astronomy and you have a fairly good scope and you put an oxygen-free, an O3 filter on, it makes the nebula really stand out, give you very high contrast, suppresses all the stuff around it.
And that one next to the Ring Nebula, just to the right of it, that's the southern ring, and that's the one that the Webb has taken a couple of images of, but this is the Hubble image.
Mhm.
What did you say the difference is between the crab and the rest of the photos?
The Crab is a supernova remnant.
Well, that's an exploding star. We're going to be talking about that, right? What
Yes.
are the others?
The others
Oh.
are planetary nebulae. That's the end result of a low mass star like our sun.
But exploding, right?
No,
No.
they're not exploding. They're puffing off their outer layers.
They're
I
bursting.
mean, in Ron, in most of them, you can see the central star, you can see the white dwarf.
So somebody dropped the ball by including the crab because it doesn't qualify, or
Yeah, a little bit, if you're calling these planetary nebulae.
Yeah.
I mean, it's not a big deal, but it's just odd.
It's a technicality.
Mhm.
Well, nebula is defined as like a planet. What is a nebula then?
Cloud.
Cloud just means cloud in Latin.
Mhm.
Huh. Well, could this be tied in, Jerry, with the addendum, the supplemental stuff you just sent us about the early warning system for supernova explosions of red giants?
Yeah,
Except it's not the same thing. Only one of those qualifies as that, right? The
Well,
crab?
yeah, well, it's a similar process of poofing off outer layers that happens before the supernova.
Okay, and we don't call it a star anymore. It's a nebula. Crab, there's no such thing as a crab star because it doesn't.
Well, there's a neutron star in the center in that case.
And they've only named one black hole anywhere, haven't they? The one in our galaxy, Sagittarius A.
No, there's lots.
Yeah.
Lots of
Well, I'm talking about with a name,
you mean like an English name?
like Sirius, Vega.
Well, there's Cygnus X1, there's all kinds of X sources out there that turn out to be black
At
holes.
some point, other symbols and numbers and alphabets start creeping into the names. So
Yeah, with black hole, you can bet they have a name like BH something or other.
yeah.
Well, our
So this
speaker-
is an artist rendering of an explosion meant to represent Betelgeuse winning.
Actually, it isn't. It's miscaptioned. That was an artist representation of what Betelgeuse just looks like now,
Oh, really?
based on imaging. Yeah,
That's surprising. There's way too much detail in that for.
I know. Well, that's an artist rendering,
Yeah. Okay.
but they're seeing that it has huge convection cells and it's bubbling and lumpy and all kinds of stuff. So
Okay.
that was
I
an
don't
artist's
see-
interpretation of that.
I don't see the artist rendering you're talking about. Can you call it up for us?
Oh, you don't see the share?
You didn't, yeah.
I don't see it. I just see our 5 faces.
How about now?
There it is.
Mhm.
And there's a
Okay.
larger graphic that incorporates that one that shows these outer dust emanations that it's barfed off, reaching, way out and completely obliterating our solar system. There's a scale on it showing that Betelgeuse would reach out to like Jupiter.
Mhm.
But as long as we're on this, gentlemen, can we go to your supplement? I want to say addendum. Red alert! Massive stars send out a warning. They are about to supernova. Can we go to that first and get it out of the
Yeah,
way?
that's what we're doing. That's why this graphic is up.
Okay, so out of where is it? In Liverpool, England, the John Moores University, along with the University of Montpelier. Is that in Vermont?
Yeah.
Yeah.
Okay, devised an early warning system to let us know, sound the alert if a massive star is about to end its life. And so we're talking about accretion disks obliterating the light.
No,
And so-
not accretion disk. This is where the star expels something.
Yeah. This is a backup to our webmaster's claim that Betelgeuse will blow up after midnight.
Yeah, I see those YouTube videos. But
He's never specific about how long after midnight, but this is the first attempt to try and predict that. A while ago, a star was caught before it went supernova and then as it went supernova, and it gave people a good look at a star in the very last months. Astronomically, that's an instant before the star actually explodes. And based on that, they made a simple rule that they're going to claim as a red alert predictor. And that is someone.
Buddy, Tom Totten sent us a message that somebody's waiting.
Oh, it says, hello, I'm here.
Tim,
See how easily I'm derailed. So,
Tim Crawford
Yeah.
got back from his doctor's appointment.
so the idea is that the disk, they've decided, well, the first warning sign is that the disk is completely obscured by material that it has previously thrown off. And as you know, Betelgeuse has been throwing off material, and I think a year ago or 2 years ago, it spent the year at about 30%, either at 30% or losing 30% of its luminosity. So it's starting to throw out these dust clouds that are obscuring it. The claim is here that when the dust clouds 100% obscure it visually, then it's within a few months of going off.
I think a better predictor is that about 15 minutes to an hour before the explosion, you'll get a blast of neutrinos.
Right.
Wow. Are neutrinos massless like
No,
photons?
they have very tiny mass.
Yeah, they're very
Really?
small. But the neutrinos are not a good predictor because I don't have a neutrino telescope.
Yeah, but there are some.
There are some, yes.
Yeah.
So if they send out a notice, then that'll be a more accurate. But like most simple rules, I think this is going to get a number of corrective terms put on it as we get down the line. But it's a good first start.
So how many neutrino telescopes are there?
Oh boy, 4 or 5.
Like the one at the South Pole?
South Pole has one I think called Ice Cube.
Yeah, there's a Japanese one. I think Chuck just mentioned it.
Yeah, Super Kamiokande.
Yeah, and then there's the one in South Dakota.
Yes.
Oh, yeah, the mine.
Yeah.
Yes.
Aren't neutrinos the one that goes right through us, right through the Earth, or am I thinking cosmic ray?
No, that's neutrinos.
Apparently, there's a lot of stuff that goes right through us, like dark matter.
Well, what does a neutrino telescope see?
It's these flashes of light. They have basically dry cleaning fluid or other heavy atoms that can occasionally, very rarely, interact with neutrinos, and they cause a little flash of light. And so they have photomultiplier tubes around these big tanks of usually chlorine containing compounds.
And they're buried in the Earth, aren't they?
Yeah, that's because you don't want other things like cosmic rays to affect them.
And the only thing that can get to them where they are is gamma rays or neutrinos, excuse me.
Wow. Okay, so we will be given a little time segment right after it goes blank, and if we won't have to worry about Betelgeuse until we don't see it anymore for a while, right?
Or it goes very, very dim.
If it looks like Orion is wounded.
Yeah.
So anyway, neutrinos, it turns out, come in 3 different kinds. And for a while, there was the missing neutrino problem from the sun. There was the number of people in the 30s, 40s, and 50s worked out the fusion reactions and neutrino production rates for the sun and thought they had it all pinned down. And then these observatories started looking at the neutrinos, and neutrinos were significantly less from the sun than
of that one type they expected.
Of the one type they expected, but it was the only one type they could detect.
Mm-hmm.
So they broadened their detection technology, and they found that these neutrinos rotate into each other. A neutrino of one type becomes another type on its way to the Earth. So that's where it went.
Well, would it be fair to say that a neutrino is like a neutron? It's negative, or it's neutral. It's not charged one way or the other. Thus
right. It doesn't have an electrical charge.
Okay, and that's why it's called a neutrino.
Yep.
And there's 3 types, you say.
Mm-hmm.
But protons also get thrown out, don't they? Without electron making them a hydrogen iron atom. They're on their own. Protons, they're positive charge, but neutrinos,
they're very massive too.
They what?
They're very massive compared to the neutrino. Very massive.
Okay, well,
this is totally off topic, really, but didn't they just recently found that protons can often have a quark component, a charm quark, that is actually more massive than the proton itself.
Yeah, I read that. We haven't talked about that because I don't understand it.
Yeah, that's real particle physics stuff.
Hey,
But,
Ron,
mechanics.
Ron?
Neutrino was of someone in order to make his, someone want to talk?
Oh, I just wanted, I had a question for Ron.
Okay.
Ron, how many pinks are there in a quark?
Depends on your wimps. But everything, all the particles that we deal with, whether in a hadron collider or whatever, come from stars. They don't come from anywhere else, do they? I mean, your photons, your light, your Electrons?
The Hadron Collider, they're producing their own version. They're producing those things themselves. I don't know what you mean quite by they come from stars.
Well,
I mean,
I know
protons
they-
can come from the original formation of the universe.
Okay, did I read somewhere that matter can get created out of nothing?
Yeah,
Yeah,
out of energy.
yeah.
The only thing that's pure energy is photons, right? The only particle that has no mass. And it's always either totally stopped and caught somewhere in an atom, or it's on the go at 180.
Energy and matter are equivalent. One's a real dense form of the other.
Yeah.
Wow. But neutrinos, what purpose do they serve, or can we ask a question like that?
Well, that's an interesting question. Back in the 30s, the early equations of quantum mechanics and nuclear fusion didn't add up. They didn't follow the conservation laws. And so someone, I forget who, made up an invisible particle that you can't detect. And he named it a neutrino.
Wasn't that
But anytime you can't detect something, people work on it and pretty soon they detect it.
Yeah, sounds like Fermi.
Yeah, I think so, yeah. And it was the joke for a while that I could get any equation to line up by making up imaginary particles. As a matter of fact, one guy claimed that he could make a model that would accurately outline the state of Texas border by making up imaginary particles.
Huh. I didn't quite understand that. What would be the Texas border? What does that mean?
It's just a shape, a graph, you know, because you can take and you can graph these particles. And he was joking about I could graph the outline of the state of Texas by making up the right imaginary particles.
But that definition you just described sounds like the WIMPs of dark matter.
Well, I don't know anything about dark matter, so if I described dark matter, it was purely incidental or accidental.
You're not a big believer yet, are you, in dark matter?
No, I'm not. It's not a belief system. I'm looking at the data and I'm waiting for conclusive evidence.
Well, you suppose a WIMP would ever make a flash in the middle of a pond
I
of
think
water?
WIMPs have pretty well been eliminated.
Have they really? Okay.
Yeah, there were searches for other dark matter particles like axions that are similar to the neutrino detectors, where they decided, oh, you know, germanium atoms or something, you know, could react with them potentially. And so they have large tanks of those, but nobody's having any luck detecting the predicted levels.
But it's valid experimental science to try to detect something and then eliminate that you can't find it, it's not there.
Yeah.
It stops these theorists from working on a lot, wasting a lot of their time.
Well, I hate to bring up a totally new subject that we don't have to get into, but it's a good thing the universe isn't balanced between matter and antimatter. If there was as much antimatter around as matter, we'd all be obliterating each other, wouldn't we? We'd be going away
It would
fast.
make an exciting universe to try and space travel in.
Yeah.
So that's not a factor in any of this. Shall we get back on the subject, or you want to change over to other things, gentlemen? It's
Back to the
almost-
program, shapes.
All right, I called it shapes and patterns, but it's asterisms are us. There's a summer triangle, the great square of Pegasus, a circlet of Pisces, and the closing credits of the Outer Limits. The old
Yeah.
TV.
Yeah, the circlet of Pisces is shown down here. The great square of Pegasus has a hidden value to it. If you travel to Australia or New Zealand and look at the sky is upside down. All the familiar shapes are upside down, but Pegasus upside down doesn't really matter.
Yeah.
So I always started the sky from that and then figured out, you know, even Orion upside down fooled me for a while. So it's a good starting point. It's my grounding anchor. But
And
the human eye likes to find patterns. We just do that. And the sky becomes like a friendly thing when you look at the familiar patterns in it.
Although in their circlet of Pisces there, they kind of left out one of the stars that's traditionally included, and it makes it look less like a circle.
Okay, wait a minute. I somehow got off the share here. Let's see.
What part of the horse is that big square?
Four body.
Oh, Okay.
He ends at the waistline. His
All
rear
right.
half cracked off and fell back to Earth and brought forth politicians.
Got sucked into the void. There we are. We're back.
Yeah.
All right.
Okay, now I extended. This is a topic that Astronomy Magazine had covered, and it was interesting. And so, but I extended that a little bit to spotting features, because when you look at things in the sky, other than the pattern of stars, which is very interesting, and you can find your own things and name your own landmarks up there. But when you look at galaxies and stuff, you tend to blur them all together in your mind, I noticed. But when you take a picture and then you work on it for a while, like 8 hours to try and get the balance right, you start noticing, you get familiar with the shapes of it. This is M101, and it's very distinctive. I know it looks like just a regular old galaxy, but it's lopsided. Most of the mass for this is off to the side. Now, you don't see that so much in your scope as an observer. What you do see, though, is one arm that sticks way out here on this side, and you can just barely see that in a big scope. But that's a good spotting feature. So when you look at M101, it's very easy to see it, to recognize it.
Just an aside, Jerry.
What's that?
Oh, just a little aside. When I built that 18-inch telescope back in 2000, I took it to Lassen Volcanic Park and aimed the telescope up at Ursa Major, and this thing just blew me away.
Yeah.
Beautiful galaxy.
It's a very bright galaxy.
Mm-hmm.
Well, is this the one that resembles a hermit crab?
No, that's coming up. That's NGC 7331. That's near the Great Square of Pegasus, and it's a good object for this time of year.
Really?
If there was no clouds. This is M74, and to me, you don't usually get three things in a line, and these three stars superposed on the galaxy in a line, they're easier to spot than the galaxy, but they're the hallmark for me of spotting M74.
And this is one of the recently released web images, shows the dust sort of skeleton of this galaxy.
Yeah, the real focused into the core, a very high resolution infrared picture. Beautiful galaxy.
So any of the determinal white spots on this are in our galaxy, right? There's
Yes.
stars.
All the stars are in our galaxy. There are faint, ill-defined things like up here, here. Those are probably hydrogen regions in the galaxy, like the Orion Nebula in our galaxy. This is too well-defined. It's a star.
But it's not one of ours, not, you never see.
Yeah, one of ours.
Okay. I
So
wonder
why would they call this the Phantom Galaxy?
This is one that's really hard to see in the Messier marathon because it's near the evening brightness of twilight. So it's got low surface brightness.
Mhm. Well, I've seen a lot of pictures of galaxies, and this is the only one that has highlighted stars in front of it. I don't know why that is.
So many of them have stars in front. Some of them, though, are in the part of the sky looking away from the Milky Way disk, and so you get very few stars there. And when I try and take pictures of those galaxies like M104, it's hard to find a guide star to guide your telescope on, unless you have a real big guide telescope. This is the one that I like. It looks like a hermit crab to me. This is NGC 7331 near the Great Square. You see these it looks like it's all curled up inside of this shell, and its legs are sticking out like a hermit crab's do. So it's very distinctive.
And it's edge on.
It's nearly edge on, so you don't see a lot of the brightness of the arms other than that, these that fling out here. It's in a region of other galaxies. It's away from the Milky Way. So you're getting more galaxies in the background.
Is this the one called the Silver Sliver? No, that's not it either. All right.
No. Now this starts the closing credits for the Outer Limits. There was a TV show, a follow-on to Twilight Zone back in the 60s called the Outer Limits. And it was they were good science fiction shows. I watched every single one of them. I made a point of checking on them for like 2 years or something. But the magic of the show was that at the end, they showed, I think, 7 or 8 astro images, black and white images taken at the great telescopes of the time, Palomar, Mount Wilson, and some southern observatories. And they just showed these for a few seconds. They were all just, they were not stills. They slowly moved in on them, giving this dramatic effect as the closing titles went across it. This is the
M67.
yeah, this is the only non-galaxy one. This is an open cluster, a very nice open cluster. It's got these arcs of stars in it.
And it's very old stars too. This is one of the oldest open clusters.
But it's got lots of little linear features in it, and that's what stands out about this for me.
I think a nickname for it is the King Cobra for some reason. I can't see that.
Yeah, I don't get that either. It could be there's a tail here and then it fans out, but that's a reach.
Yeah, Jerry, what I remember about the Outer Limits is they used an oscilloscope and they constructed Lisa drew figures on the oscilloscope, which we did at Westmont, my electronics lab. It's a very straightforward exercise.
Yeah, that was at the opening credits when they said, we're going to take you from the inner mind to the outer limits.
Right.
That's right. And they were also going to control the volume, the horizontal.
Don't try to control your TV. We have control. This is the silver, whatever it was, silver sliver.
Sliver.
Yeah, this is NGC 891.
Oh, yeah, and Andromeda, that's a beauty.
Yeah.
And that was part of the closing credits?
All these are. I went and dug up pictures of each of the 7 closing credits.
Including that star cluster.
Yeah, it started with the star cluster. These are in order. They showed them at the end of the TV show.
Does the star cluster have a Messier name or number?
No, it had
a 67.
Yeah, a new general catalog number from Herschel.
Right. This one's a Messier, Ron.
Yeah.
M104.
Yeah.
Sombrero.
Yeah. And this is the sombrero. And this is the one where, despite this star, it's about the only star that I can guide on near it.
Yeah, yeah.
So I have to use a rotator to get to it.
Jerry, so the Outer Limits, that would have been all black and white TV, right? No color
That's right.
TV.
Yeah, all black and white. So what I'm showing you is color versions from this era, and they're taken with telescopes and spacecraft that weren't available then. Those pictures were all black and white of these objects, and they were taken at usually at Palomar or the 48-inch Schmidt camera at Palomar, the 200-inch or the 100-inch at Mount Wilson.
Now they did color astrophotography by using different filters, right?
No one that I know did that in astronomy. The common thing was, it was very rare to see a color picture, but you could do that by taking different filters on black and white film.
Yeah. The problem with 104, of course, is it's pretty low in the sky in the southern sky.
South. Right.
But I did see it in a 61-inch in Tucson, which was pretty impressive.
Mm-hmm.
So this is the sombrero you're talking about?
Yeah.
Yeah.
Beautiful galaxy.
Does it not have arms?
It's edge on, Ron.
It does, but they're hidden in here. The neat thing is this dust ring around the edge, and on a really high resolution picture, which this is not, you can follow the inner ring of this dust ring. You can see structure in it around there. I don't think this is considered a spiral galaxy.
It's a fat nucleus spiral.
Yeah.
Yeah.
Okay.
Yeah.
Looks like a galactic version of Saturn.
Yeah.
Could
Conservation of angular momentum.
I suppose, yeah. Wow. You know, one of my favorite shows in the 50s, I tried to call up, seeing if YouTube would rerun for free the old science fiction theater. Remember that? Half hour?
Yeah.
And you can't get them. And I'm wondering about the Outer Limits, if you can call those up for free, or do you got to pay for them?
I didn't try, but I'll bet you you could find them if you wanted to.
Well, Totten, you could probably look for them, call up a version, see if you can find one. You won't find science fiction theater, but I used to love that. I remember one particular program too, and usually you don't remember the plots of any of those old shows.
Yeah, according to the search here, it shows that YouTube does have some Outer Limits episodes there, full episodes.
Mhm.
The special effects in Outer Limits were not that great. Nothing by today's standards. You can even recognize the stars that were the monsters sometimes.
Yeah.
So this is NGC 5128.
This is Centaurus A, right?
Yeah.
Yeah.
Elliptical galaxy?
This is a collision between an elliptical and a spiral, so you can still see the remains of the dust lanes from the spiral.
It's writhing. Now the next one, this is NGC 1300. This, by coincidence, was the astronomy picture of the day for yesterday.
Really?
This is a dramatic, detailed picture. It's a barred spiral. These are straight across in the middle, and then they go into a spiral arms. This is very much like our galaxy. Ours is a barred spiral. I don't know if the proportion of bar to spiral is the same as our galaxy or not, but I think our galaxy has more of the arm structure.
Mm-hmm.
But I haven't viewed our galaxy from this angle, so I can't comment really.
But the current guess is that it has more spiral arms.
Okay.
But I still don't understand how the bar itself, both ends of it, the stars have to go faster than the ones in the middle.
Nobody else does either.
Really?
No, I haven't seen any convincing discussion of why there's a bar and how it's stable, or if it's just a passing phase.
Well, we're in a barred galaxy, aren't we?
Yes.
We are. We just, within the last decade, I think we figured that out.
And
Maybe
even the Large Magellanic Cloud has some bar structure.
Okay, that's right.
Well, our guest speaker coming up in 2 weeks on November 5th is probably going to take us there and tell us.
Mm-hmm.
That's his specialty.
Well, that reminds me, I had a visit yesterday from my godson. He works at JPL, and he's the guy that writes the software for the helicopter on Mars.
Really?
Yeah, programs it and tells it where to go and how to define where it is. And we were talking about that. The helicopter, there's, the Perseverance rover up there right now is going around sampling rocks and leaving little vials or storing them and gonna leave them somewhere, and they're going to be picked up. And they're planning to put a rover up there to go around and pick these things up. But the helicopter has been so successful. I forget what its name is.
I do too. I'm trying to remember. Starts with
Helicopter is Ingenuity, I think.
Yeah, okay. That's right. Ingenuity, it's so effective at this that they're currently modifying the other one they kept back at JPL, changing the pitch angle on the blades and the speeds and stuff. And they're going to make it so it can carry a heavier load. And they're now going to use the helicopters to go around and pick these vials up of sampled Mars material and bring them back to a launch vehicle that will take off and bring them back to Earth. The requirements for the doing that with a new rover going up, it didn't work out so well. There wasn't a big enough margin for because the rover was required to be too heavy to make. And Mars, is hard to land on because the atmosphere is very thin. So there's not a lot of braking there. So it needed a very gigantic parachute, and it was heavier than what's gone up there before. So they're now going to use these helicopters. We're going to see a lot more of them. There's been a contract let for, I guess, 3 more helicopters. And they're planning on also making a couple of these helicopters to fly on Titan within this decade. So a lot of things are happening. Now, if we need a speaker in the future, I think he said he would be amenable to do that. So
you provide me with his name and number or email address, I'll call him. But where do you suppose that Ingenuity replugs itself in to get new battery charge?
Solar panels.
Yeah, solar panels.
It's got solar panels on it. Oh, okay.
Yeah.
And there's
So
enough.
it plugs itself into the sun.
And there's enough of that sunlight coming in on Mars.
It's about half as intense as it is here on Earth.
Got it. Yeah, I'd love to have him on next year.
Okay. So I'll see if I can make the connection.
Already?
So
What is this?
this is M81. I think this is called Bode's Galaxy.
Mm-hmm.
It's a beautiful spiral. I don't see any crossbar in it, but this was the second to the last one it showed. remember this, what you would see on TV then, you'd see the black and white version. And then it finished with the queen of all galaxies up there, Andromeda.
Or the princess.
She's a princess.
Yeah.
Princess. Oh, that's right. Excuse me.
You suppose if you were on an intelligent civilization on a star inside the center area where it's all brightly lit, would there be a night sky at all?
Oh, yeah.
There would.
Yeah. It'd be full of bright stars, but yeah.
Huh. You'd actually see black.
It just looks dense from so far away.
There's a lot.
I'm just going to take a wild guess here and say that we're probably, if this were our galaxy, we're probably around where the hand is, somewhere around in here. And you can see that we see a haze there from it, from all the star clouds. But yet, when we look at the sky, we don't see a lot of stars around us that are obscuring, that are causing night to be too bright. But we'll get to that in a moment.
Okay. Looking forward. No bar.
Okay, you have some questions in chat.
Okay.
Tom, you want to tell us? Tom Totten?
Just James Williams says he wanted to find that sequence of deep sky objects, and it credits Outer Limits, which is there is a astronomy.com does have that article that you can see that. And to Neil Malone, that's right. There's an astronomy.com article that Jerry's referring to about this Outer Limits images that they had. And then Jim comes with says we need that photo mission to go outside the galaxy plane for a photo op.
Yeah.
Good luck on that one.
Yeah, it's in as Tom points out, it's in Astronomy magazine from I think 2019, if I recall correctly, which I sometimes do.
Back in the 50s, when Outer Limits was on, all they had was Earth-based telescopes. So I'm sure the galaxies look much better these days through Hubble and now Webb.
Yep. So this one is this is the new Comet.
Ah, here we go.
It's up here in the west northwest. This is at 7 p.m. Tomorrow night, but it won't move that much if you look tonight, if the skies are clear. We've had some rain and clouds here. So this is setting. Later in the evening, it won't be here. But this is where the comet is now. It's not that bright. It's expected to brighten up to about magnitude 6 or 7, which is barely visible under a very dark sky.
And that's integrated magnitude, so that's wishful thinking.
Right.
But we don't have a generic name for this new comet like Pan-STARRS, do we?
Well, Pan-STARRS, this one is ZTF. Okay, that's Wiki Transient Factory, just the way Pan-STARRS is a system that discovers a bunch of comets. There's no one Pan-STARRS comet. There's a whole bunch of them.
Okay.
This is E3.
Okay, so this is C 2022. C stands for comet. There's a slash, and then obviously the year it was first seen, this year, right?
Yeah.
Uh-huh.
And then the E3 tells you when in the year.
And we'll see it good. We'll be able to see it next year, won't we?
We hope.
With the naked eye.
I wouldn't bet on that.
Well, that's what it said in the talk.
Jim Williams pointed out that Ingenuity was named by a kid.
Yeah.
Oh,
They had a contest, as I recall.
Little girl.
Okay.
they keep coming up with great names.
I liked Bodie McBoatface for that icebreaker they were making. And it won, but they copped out.
I still think they should name a moon around Uranus colonoscopy.
Go on. Now.
Those are traditionally named after Shakespearean characters, and I don't think there's a Shakespearean character with that name.
Not even Cologne or colon. All right, what are we looking at here, Jerry?
Okay, you're looking at, I'm going to make it a little wider. You're looking at Orion.
Mm-hmm.
This is at 5:30 in the morning, this coming Friday, the 21st. And the reason we're looking at it is this is the radiant for the Orionid meteor shower. Not a big shower, but it will be in a dark sky. The moon right now is at last quarter, So this will be very close to, if not at, new moon. So you should stand a chance around this time early, just a few hours before dawn, of seeing meteors. They will be all over the sky, but they will appear to come from here.
Yeah,
And
and
this is actually,
Barry, when Orion's aligned that way, you're pretty much looking south.
yeah.
Huh.
And this is actually one of the better showers of the year, and it coincides with our camp out. And I know that at the camp out, when I've stayed up late, you sometimes get a nice show. From this shower.
Excellent. So Jim Williams wants to know, what was the last comet named by a person? I don't think that
By a person or after a person?
After a person, or the person's name.
Well, I know there was Borisov pretty recently, and probably a couple of others.
Yeah, Gerasimenko or whatever it was.
Churyumov, Gerasimenko,
Yeah.
It was a comet that deteriorated over Jupiter, right, in the late 90s?
No, there have been much more recent ones that are named after people. I would have to look that up.
That was Shoemaker-Levy you're thinking of, Ron.
Yeah.
What was Hale-Bopp?
Hale-Bopp was Alan Hale and Thomas Bopp.
Sooner than that, or more?
That was 97.
Okay.
Yeah. Mm-hmm.
But those were comets. The one that crashed into Jupiter was a comet. It wasn't an asteroid.
That's correct.
I had two elementary school age children at that point, and I woke them up in the middle of the night about 3 o'clock to look at Hale-Bopp through a telescope. Then a few years later, another comet came through, and I mentioned it at the dinner table, and in unison, both girls said, or both children said, "Don't wake me."
Yeah.
That other one, Jerry, might have been Ikea-Seki. Does that make sense?
What's that?
Yep. Ikea-Seki?
Yes, that sounds right.
Yeah.
Well,
Yakutaki also.
Wikipedia says that the earliest comet to be named after a person was in 44 BC. Anybody guess who that was?
wasn't Haley.
Is that after assassination of?
Caesar, one of the Caesars.
Very good, very good. Julius Caesar. Yeah.
But what was the most recent?
Good question.
So there was a guy, I read about this. I should have put a note in here because it was very entertaining, but I forget the guy's name, and everybody forgets the guy's name because he was back about the time of Edmund Halley, who had a comet named after him, a periodic comet. This guy had also looked through records, and he'd found a comet, a very similar comet, that came back with a period of about 100 years. And it turns out that he was wrong. They were two different comets. And so when he made a big prediction about when it would return and it didn't, he lost a lot of status. And astronomy was a tough game in those days.
Well, do they all return?
No.
No.
These showers, the Orionid I've never heard of before, the Perseid and the Leonid I've heard of, but it only you name that because the radiant is the Orion Nebula, right?
Yes.
From which the rocks fall.
Nebula, the constellation.
Okay, but every one of them is based on the remnants of a tail of a comet going by Earth at some point, or at least we're going through the tail.
Or an asteroid.
Or an asteroid.
And Ron, the Orionid shower, which is the one coming up this weekend, is pieces of Halley's comet.
It is.
Yeah.
Okay, well, we do get to see that one every, 80 years?
76.
What would keep us from going through several versions of its tail and having several?
We go through twice. There's a springtime shower and the Orionids. I can't remember the springtime one, though. Lyrids are, that's not it, but there's a springtime shower.
Yeah.
Well, Jerry, in your, we only have 10.
Ken Kellstrom and Chuck and I braved the weather on Friday at Westmont because there was a chance of having a homecoming group of people coming through. It didn't happen. But Ken started talking about Halley's Comet and then Chuck did too, because Chuck was in town when Halley's came through. I was in Tucson and I actually saw it in late 85 or early 86. That'll be the last time I see it. And then what was really interesting was Ken raised his daughter up, I think he said it was 4, to see Halley's Comet. and she has a pretty good chance of seeing it again.
And by the way, Tom, as I
Yeah.
was leaving, when the sprinklers finally turned off, a carload of people showed up for
So
Ken.
we got some.
Well, I didn't count them. I was leaving, but Ken
Yeah.
got them.
Oh, good. Okay. Yeah. Yeah. I just learned out about that outreach that morning from Ken. I didn't realize it was homecoming at Westmont, and he put together a viewing the previous evening.
Jerry,
So-
is this the stars next door part of your talking point?
Yes, it's the
Yes.
start of that.
That's fascinating. Could I say one thing?
Please.
just
Imagine a giant bubble in our nearby space, 30 light years across, with the sun at the center, 30 light year diameter sphere in the part of the Milky Way. How many stars would be inside? With sun at the middle of 71? Is that the word?
That's what they have, I think.
okay.
There's a
And-
great display of this at the museum in the planetarium, in the planetary lab there next to the planetarium,
Yeah,
Call us-
71 stars. Yeah, excuse me. Go ahead.
Okay.
called a Stellarium. And basically an artist has gone and put fiber optics in this large dark cage, and their brightness level roughly corresponds to the brightness of the star. And then they're distributed in their distance from the sun.
Mhm.
And so you can press a button for certain given stars and it'll highlight them. So you can see where Sirius is and where Vega is and where Proxima Centauri is.
Yeah.
And I was actually doing planetarium shows yesterday, and I played with that. And it turns out that when you pick the sun, the two indicator lights come on, but the LED for the sun is burned out. So you know,
That's pretty good.
So it should be forming, throwing off its outer shell then.
yeah.
So this diagram is very enticing, but it's low enough resolution that you can't actually read what it is. It says sun there.
Mm-hmm.
I looked around on the internet quite a while and I could not find a one that you could read there, and it's a little confusing. So I think it's not everything. I mean, it's got other things added in. This word is Procyon, and Alpha Centauri is this yellow one. Alpha Centauri B is the other yellow one.
That's
Proxima
interesting.
Centauri is this red one.
That's interesting because Procyon is farther away than Sirius, and yet in there it looks almost closer. So it
Yes, it must
3D
be
effect.
it must be through there. And this is Bernard's star, the red one up here. But other than that, this one looks like Lyson's star or something.
Yeah.
So
Layton star.
yeah,
A lot of those are little red
Also,
dwarf
Jimmy,
stars.
Yeah, and
all
that's the point of this article. Go ahead.
Oh, I was just gonna say, notice all the little red dwarfs.
Yeah.
Tons of.
Yeah, and so this one is a picture that shows Alpha Centauri A and B overexposed up here, so you could get Alpha Centauri C Proxima to show up. So this is the one that's closest,
Okay.
and these are nearby. And those are obviously our closest one.
Mhm.
This interesting table, whoop, is barely readable. It shows the spectral types, the color that goes with surface temperature, and the spectral lines that are in the surface. But the two interesting things about this are future close passages to us.
Including Sirius.
This is Sirius. This is Leyland's star, which I guess is the one that was shown there. This is Bernard's star.
Yeah, very
This is-
fast.
Proxima and Alpha Centauri. 27,000 years from now, that will be where it is. And here's Gliese 710, which in 1.36 million years will actually be inside the Oort cloud for us. This is the Kuiper belt, and this sphere around here that transitions from it, this is the Oort cloud.
Wow.
This stuff is, go ahead.
What'll that mean for our planet if it does go inside that shell of rocks?
A lot of comets.
Yeah, it means a lot of orbits in there are going to get changed.
Mm-hmm.
And some of them will be flung out into space and some of them will be flung toward the sun.
Mm-hmm.
Wow.
But of course, it'll probably take a couple of hundred to a couple of thousand years for all those comets to arrive.
Yeah. Yeah, this is not a trivial distance here.
But then it'll go on its way and leave the Oort cloud. Why wouldn't it start orbiting our sun where we become a binary?
This does
Because
not
it's
start
not-
orbiting. See,
Yeah.
the path is here. It's going to just pass through.
Mm-hmm.
Huh,
Yeah, we don't
And,
have enough gravitational force to capture it.
Right.
really?
That's a neat graphic, Terry.
And this is, thank you. Not mine, but I found it. This is about 1 light year. See, this
Okay.
about 1 light year. So this is 4 light years where,
Mm-hmm.
Alpha Centauri, Proxima Centauri are. They're out about here now. They'll be in here about 3 light years as close as they get.
And these
Wow.
aren't the actual paths because they will probably come at different angles. Well, I guess some of those are different angles. I was going to say it looks like they just put them all on the horizontal here.
Yeah, I think they did that. You're right. They're just showing radial distance with time.
Yeah.
Sure. Yeah.
So
Does modern science think that most, if not all, stars have some version of an Oort cloud themselves?
I don't see why our sun would be so special.
Mm-hmm.
Yeah, okay. And those rocks out there in the cloud are even further apart than the ones in the asteroid belt.
In general, yeah.
Yeah,
You'll never see a big thing that obliterates a lot of the starlight because it's opaque almost.
not that I know of from our Oort cloud.
Yeah, right. We know they're out there. What is
That
this?
would be a Dyson sphere.
This shows the distribution of our neighbors in terms of type of star.
Mm-hmm.
These are all red dwarfs down here. These are solar-like stars. There's the sun, these yellow ones, Alpha Centauri A, Tau Ceti, Alpha Centauri B, and let's see, where down here is Alpha C Centauri.
You looking for Proxima?
Yeah,
Mhm.
I don't know that it uses the name Proxima here, but
Yeah.
Mm-hmm.
Yeah, it's there.
Give them crap. You got a question.
It's
Yeah, there's
there.
Proxima.
Yeah,
They've got
just
it as
about-
Proxima.
Oh, there it is.
Right
Yeah,
there.
yeah, got it. The X looked like an S. It was my spotting feature. And over here we have some white dwarfs. They've had a very interesting pass. Van Manen star, Procyon B, and WD 1142 645. Never heard of that one before.
Yeah,
There's
very
Sirius
hot.
A, so this is Sirius, what we see, and this is the pup for the dark star.
Huh. And white dwarfs are on their way to becoming black holes, or some of them.
No,
No,
They're not incredible like neutron stars. They're not.
no.
this is their end game. This is where they have lost it all and they're just cooling off.
That's where the
Ah.
sun will end up.
Yeah. Most stars, as you go down in size and temperature, most stars are at this end. And most stars in our neighborhood are at this end.
Mhm.
Population wise, yeah.
Yes, population-wise, number-wise.
Huh.
Yeah, that's a Hirschsprung-Russell diagram, Ron.
Yeah.
Yeah, nice one too. You see the blue's real hot, Ron, over on the left there, real hot. But they're not real massive, this whole bundle of white dwarfs.
Well, have any of you seen reports that the Webb has detected something on Proxima Centauri B, the little planet going around the red dwarf?
No, that C is the red dwarf.
Okay, well, the closest exoplanet to us is Proxima B, isn't it?
Yeah.
Proxima Centauri B.
No.
I keep.
Oh,
seeing-
yeah,
I
yeah.
keep seeing YouTube videos saying we've detected city lights, and I don't even open them. I know it's not fair.
Hey, I can direct you to websites that show a face on Mars.
Yeah.
I just wonder if it's picked up something. Webb has seen something
Not
happening.
yet. But there is a plan to look for that. They're looking for more energy coming out of it in a narrow
Right.
spike that on the night side that would indicate something maybe a city or something there. The Earth certainly puts out a lot of stuff on the night side.
Oh, yeah. Tom Totten, what did Tim Crawford have to ask?
Well, he was asking about, well, before that, Jim was talking about predicting comets that didn't happen. His grandmother saw Halley's from a horse-drawn cart, and she was alive, but she didn't want to see it the second time around.
Don't wake me up.
Yeah, don't wake me.
Yeah, and the famous story is about Mark Twain, right? So Mark Twain, when he was a little baby, was lifted into the sky when Halley's come through in the 1830s, Chuck, maybe something like that, 1830s, 40s. And then just before he died in 1911, he saw it. So he actually saw Halley's Comet 2 times.
Yeah.
Cool.
Well, you remember that story of the cult based in San Diego that committed mass suicide so they could jump on board spaceships following a comet?
Right.
That was a guy named Applewhite or something like that.
Yeah.
What was the name of the comet? Anybody know?
Hail Bob.
Oh, was that the Hale Bopp?
Yes.
Damn. All right.
Yeah.
Well, gentlemen, we're over time, but it's fascinating stuff. A little scary. 29 million years. No, how many years before Gliese goes into our Oort cloud? Have I got time?
1.3 million.
Oh, I won't worry about it then. There it is. Any day now, right?
If our solar modeling is right, the sun will get hot enough to boil off our oceans and atmosphere in about 800 million years. So I wouldn't worry about anything.
That'll just will happen after midnight.
Yeah.
All right. Well, everybody, we'll
All right.
see you this weekend at the big camp out. It's Friday through Sunday, and I hope I can make it. I hope I've signed up, and the rest of you take care of yourselves. And make sure you eat some sourdough bread from the Whitmore Kitchens. Both Toms, Jerry, and Chuck. We'll see you next week.